So hopefully everybody did a good job on just regular frequency tables. So now what we want to do is talk about a grouped frequency table and when we would actually use a group frequency table. So group frequency tables are going to come in handy when we have data like we have below here, where we've got a bunch of decimals and things like that. There's not a lot of repeated numbers. So if we were to fill these out as just a regular old frequency, we'd end up with our frequency being a lot of times just a bunch of ones with a lot of zeros in between if we were trying to fill in every single number. So our goal whenever we're making a frequency distribution is we want to make sure that each of the categories has enough numbers in it that it's worth having its own category for. So if we've got a bunch of data that's spread out between like 1 and 100, then we definitely don't want a frequency distribution that has a bunch of individual rows 1 through 100. So in that case, it would be better to break it up into a bunch of different classes, maybe 5 or 6 classes, where we can get a significant number of elements in each of those different classes. So when we're looking for our group frequency table, again, what we're going to do is we're going to divide them up into some number of classes. So that's either going to be given to us, or it'll be, or if we're doing it ourselves, we can decide how many classes we actually want to make. So you'll have to just look and see what the problem asks for. So the classes have to be the same width. So that's really, really important. So we want to make sure, like we may decide to make our class width 10. So we want to make sure, we're going from like 1 to 10, 11 to 20, things like that. So we want to make sure they're exactly the same width as we go along. So we want to make sure that the classes don't actually overlap. So everything has to fall in one category or another. And I'll show you how that works when I actually lay out my frequency distribution, so you can see how that works. So again, we want to make sure there's enough classes to cover all the data. So we don't want to have numbers left over on our list that don't actually fit anywhere. That wouldn't be good. And if at all possible, we always want to try to avoid empty classes. Now, sometimes, depending on how spread out the data is, we may end up with an empty class in the middle, but we definitely don't want to start with an empty class, and we don't want to end with an empty class, because those would have not been necessary. But again, if our data is really spread out weird, it is possible we could have a class in the middle that might be 0, and that's okay. We don't want to eliminate that one, but we definitely don't want to have a 0 class to start off with, and we don't want to end with a 0 class for those. All right, so the most important part for our group frequency distribution is kind of figuring out which category it falls into. So what we've got 2 different scenarios that we're looking at. So we can either start off where the class width is given, but the number of classes is not given. So if the class width is known, then that makes everything kind of easy. We know where to start and stuff like that. And so now we just want to choose a certain number of classes that make sure all the data is actually there. So what you'll do is just kind of use the class width to keep building classes until eventually all the data points are taken care of. So that one's a pretty straightforward method. So the other one, the number of classes is given, but we need to figure out what the class width is. So to calculate our class width, what we're going to do is use this little formula here, where we're going to take the largest value on our list, subtract it from our smallest value, and then divide it by the number of classes. Now when we do this, there's no guarantee this is going to be a whole number, but we do want our class width to be a whole number. So what we want to do is we want to take whatever answer we get, and we want to round it up to the next whole number. So we're always going to round this up, even if normal rounding rules don't apply. So always round our class width up to the next whole number. So again, even if normal rounding rules don't apply, we're still going to do that for these. And so again, we want to make sure we round it up, because if we don't round it up, then there's a possibility that some of our data values at the upper end of our data won't have a category to fall into. So that's the reason we want to make sure we round that class width up. All right, so let's take a look at one of these and see if we can figure out how to do it. So for example 3, we've got the following wait times. Again, notice they're all decimals and stuff like that. We want to construct a group frequency table for the data above using 5 classes. So in this case, since we're given the number of classes, we need to find the class width. So we're in the second scenario here. So what we need to do is first calculate our class width before we do anything. So our class width is going to be our largest value minus our smallest value divided by the number of classes. And so our largest value in this case is going to be our 17.4. Our smallest value is going to be our 0.6. And then finally, since they told us originally that we wanted 5 classes, we're going to divide this by 5. And so if I throw this in the calculator real quick, looks like I get 3.36 as my class width. And so again, I want to make sure I round this up to a nice whole number. So my class width is actually going to be 4 for this. So now that we've got our class width, what we need to do is figure out how we want to actually lay out these different classes. So that's going to be determined by what our data elements actually look like. So if, say, for example, our numbers started with like 100 was one of the smallest numbers and went up to like 1,000, then we wouldn't want to start our group down here at, say, 0. We'd want to start at that 100 and then kind of grow up by 4s from there. So for us, since our smallest value is 0 and our biggest value is 17.4, or 0.6, sorry, then what we want to do is go ahead and let our lowest value be 0 in this case. And then what we're going to do is we're going to go from here up to 4, but not including 4. So notice that I used a strictly less than for that 4. So anything that's smaller than 4 is going to live in this first row. Anything that's exactly 4 is going to live in that next row. So again, this is where we want to deal with that, no overlapping, every place has its own category and stuff like that. So that's how we deal with this, by setting kind of the upper bound of the elements to be a strictly less than, and the lower bounds to be a less than or equal to. All right, and so we'll continue laying this out until we've got all 5 of our categories. So if I add 8 to 4, I'm going to get 8 down here. And if I add 8 to 4, I'm going to get 12. And then start my 12 here. Add 4 to it, I get 16. Put my 16 here. And then finally, if I add 4 to that, I end up with 20 in that case. So now I've got my layout set up, and so that's usually the trickiest part. So from here, it's just a matter of counting, making sure we get everything into the right category and things like that. So I'm going to go through and count. So anything that's less than 4 is going to go in our first column, or first row. So if I go through, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got 11 numbers that are less than 4. So now I want to pick up any numbers that are between 4 and 8. So I'm going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in this case, notice we do have 18 exactly, or 8 exactly on there, but since 8 exactly is going to go in the next row, we want to stop there, and that's going to be our 16. So now we're looking for things that are equal to 8 but less than 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've got 16 of those. So now we're looking for things that are equal to 12 but less than 16. So it's going to be 1, 2, 3, 4, 5, 6. And then finally, things that are equal to 16 but less than 20. So it's just going to be 1 exactly. And so again, just like I mentioned above, when we do our frequency, what we want to do is go ahead and add these all together and then compare it to our list just to make sure that we haven't missed any or anything like that. So I've got 11 plus 16 plus 16 plus 6 plus 1 gives me a total of 50. And if I look above, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 elements across, 2, 3, 4, 5 rows. So if I do my 5 times my 10, I get my 50 there as well. So that's perfect. So that means we've got all the elements, we haven't missed any or anything. All right, so our relative frequency is just like the same as above for our group frequency. So we're just going to take our frequency and divide by the total. So we've got 11 divided by 50, 16 divided by 50, 16 divided by 50, 6 divided by 50, and then finally 1 divided by 50. And then again, if you wanted to throw these into percentages, just so it makes a little bit more sense, we'd get 22%. So we're going to get 32%, 32% again, 12%, and then 2%. Now this one, since we were lucky enough that we didn't have to round, everything was a nice whole number, when we add these up, again, unless we made some kind of a mistake, this one should equal 100% exactly. All right, so work on practice 3, and that would be it for frequency diagrams. So again, if you have any questions or anything, just send me a message and let me know. Good luck.